Hello everybody, this is Cranky Calculus here for our video here on BC integration techniques. I'm going to go over an old FRQ that I made. And I'm going to have some multiple choice in here too somewhere. Yeah, multiple choice in here, FRQ. So yeah, let's go ahead and get rocking and rolling on this thing here. We have a continuous function. F is defined by f whenever x is bigger than or equal to -4. The graph of f shown below consists of two inline segments, two portions of the parabolas, and a known curve. The graph has horizontal tangents at -1 and x equals 1/2. It is known that f of x is going to be 8 ln of x over x cubed for x is bigger than or equal to 1, which is going to happen right here. The areas of a and b bounded by the graph of f and the x-axis are 4 and 2 respectively. Let g be the function defined by g of x is equal to the integral from -2 to x of ft dt. Holy cow, there was a lot of information on that thing here. Way too much for me here. So what I'm going to say is you kind of need to know what the heck is going on. Okay, so pretty much. Let's start with this A and B. I think that's what's staring us at the face. Those are defined areas. But those are just some parabolas. We know what those areas are. They give them to us. They say the area of A is 4 and the area of B is 2. But since B is underneath the x-axis, we're actually going to put the -2 right there instead. We know that this entire thing here is continuous. We do know that this function right here, this is my f of x function. This is going to be 8 ln of x over x cubed. That's what that little portion is right here. Actually, I'll shade it in green for you so you can see it. So this entire shaded green part right here, that is that function. And then g of x is just its own integral thing. So we got a lot of stuff going on in here. Man, what a great FRQ. I wonder who wrote it. So let's go ahead and find g of 1 and g of -4. This is actually not that tough. All we're going to do is just substitute in these values into g. So for g of 1, I'm going to leave g of x in that corner right there so you can see it. So for g of 1, that's going to equal the integral from -2 to 1 of f of t dt. So we're going to find the area from -2 to 1, which I have all that stuff. That's actually going to be a minus b, or really, because b is on the bottom, that's why I'm saying minus b, but it's going to be that 2 minus 4. Or sorry, I'll say it right this time, 4 minus 2, because it's that a value, which is +4, that b value, which is -2, and it's going to give us an answer of 2. Okay, not hard. G of -4. We're going to go ahead and integrate from -2 to -4. f of t dt, if you notice here, the order of that is not what we like. So let's go ahead and negate that and switch that order from -4 to -2 of f of t dt. And now we can actually get this area right here from -4 to -2. Oh, if I can just draw this out right here. This looks like a triangle here and then a trapezoid. I'm just going to cheat, look over my key right here because I'm trying to retire from this video business here. Don't have time to make this video, but hey, I'm doing it for my students because I feel like I got roped into it. Anyway, we're going to get that area to be 2.5. Don't forget that negative out in front, so it's actually -2.5. And the reason the area is negative, even you're like, wait a minute, it's above the x-axis. Yeah, it sure is, but the function starts integrating from -2 onward to the right. So since we have this area right here is to the left of where I'm starting, that's why it's negative. Okay. For the next part here, for part B, with all this stuff, we're going to find the open intervals in which the graph of g is concave up, starting from -4 moving onward, and we're going to justify our answer. So if g is concave up, that means I need to find the second derivative of g. Well, g of x is going to be this integral defined function right here. So I do know that g prime of x is going to equal f of x. That's using the second part of the fundamental theorem of calculus, and g double prime is equal to f prime of x. So essentially, whenever our f of x is, when f is increasing, that's when g double prime is positive. This is what I'm looking for. When f is increasing. So we can just tell when f is increasing. It's going to increase in this red part right here. It's going to increase from here to here. Luckily, we do know that where this stops at because we do have its horizontal tangent. So this is definitely at -1. And then we are again good from here to here. And I do know this as x equals 1/2. again, we are given that information right above here. And then it looks like I am going to be increasing from here until about here. We need to figure out what this point is right there and where that stops. And I can do that because I do know that f of x is equal to, I must have circled it earlier, equal to that value right there. So if f of x is 8 ln of x over x cubed, then I can find that derivative, and I'm just taking the derivative for this just for this little tiny portion so I can find out that value right there. That's all I care about is that value. So let's go ahead and do that. Let's find f prime. So f prime of x for this part of our f of t function is going to equal, oh, this is this quotient rule, isn't it? Quotient rule, so low d high, derivative of the top is going to be 8 over x minus high d low, derivative of the bottom there is going to be 3x squared all over x cubed squared. I can clean this up a little bit here. I'm going to get 8x squared minus 24x squared out of x over x to the 6th. I can take out a GCF on the top of 8x squared, which is going to give me 1 minus 3 ln of x all over, ooh, that's a bad line, x to the 6th. I just need to set the top equal to 0 because I only care about this function is when it's larger than 1. This is going to tell me stuff down here about 0, which I don't really care about. I only care about values when x is 1 or larger, so I'm going to set this equal to 0. And I only care about this factor right here. This is 1 minus 3 ln of x equals 0. The reason, again, I only care about this factor is I only care about when x is larger than 1. This 8x squared is going to deal with a 0, and this x cubed is going to deal with a 0. So I don't care about those. I'm going to get x to equal e to the 1/3. If you didn't know how I did that, it's probably not the class for you. You just solve for the ln of x. You add your 3 ln of x to both sides. Then you raise both sides to the e, you'll get e to the 1/3. So now I know what this value is. This is going to be e to the 1/3. And now I can say that this function, so g is concave up. And I'll say in because it wants open intervals in between. It doesn't really include that -4 or not, but it just says open intervals, so I'll do that. -4 to -3. I'm just reading my graph at this point. I already did all the hard work to read my graph. From -2 to -1. And from 1/2, that's actually going to continue all the way through. Because it does say it is differentiable, continuous, all the way until e to the 1/3. Yeah, and that's because g double prime is positive. Okay, so let's go ahead and now move on to the part that probably does involve these integration techniques. They do appear at some point, but usually when you're doing Fourier responses, especially in the AP exam, they will throw in some older topics as like part A and part B or whatever, and then they'll just nail you with a, I think out of nowhere, like, whoa, what is this integral type of thing with like a part C or part D? And I think that's what's going to be coming up right here. Okay, part C, find the limits as x approaches infinity of g of x, or show why it does not exist. So g of x, by the way, is this right here. So what I'm going to be doing is if I take this limit, I'm going to be doing the limit as x approaches infinity of the integral from -2 to x. This function right here, which is going to be, I'm actually going to change some things around a little bit, just so this looks a little, this is f of t. I don't need to change anything around. So I'm going to rewrite this f of x right up here, and I'm going to write that in terms of t because this is an f of t dt. So this is going to become, oh, I have it right above me right here, 8 ln of t all over t cubed dt. All right, so I need to solve for this. Well, we have these values between -2 and 1, the x values, so I can actually write this as, and I can find this out because I already did this, right? That's just 2. So from here to here is 2. Just check to see what I did in previous years. Yeah. So this is the same thing as the integral from -2 to 1 of f of x, or f of t dt. plus the limit as x approaches infinity of 1 to x 8 ln of t over t cubed dt. Yeah, so then this right here just turns into, which I have it, it's right here, turns into 2. Plus, oof. Yeah, I think so. We got maybe some u sub over here. What I'm gonna do is I usually like to, for these, I don't like doing the bounds. I'm gonna go off and do some side work here. This looks like some integration by parts. This is a heavy one. So let's go to some integration by parts. I'm gonna take that and I'm gonna rewrite that over here in pink. I'm gonna solve for pink and we're gonna be good to go. So it's integrate t to the -3. I'll put an 8 in front of that. ln of t dt. Solve for pink, and I'll replace pink with that blue, and we'll be good to go. By doing integration by parts here, we're going to use the tabular method. So whenever I do this, I am going to have my u value, my v value, plus there, minus there. I'm going to have my u value be the ln because I cannot take the integral of an ln function without it doing more integration by parts. So this is going to be ln of t. This is going to be t to the -3. That's supposed to be a v, by the way. So I'm going to get 1 over t, and then the derivative of this, or sorry, not derivative, integral. Oh, okay, so it's integral. It's going to, if I add 1, I get -2. So I'm going to divide by 2t to the -2. Yeah, that's what I got in previous years. Can I integrate this bottom part? If I multiply those two together, can I integrate that? That turns into the integral of -1/2. It's really t to the -3, is it not? Yeah, it totally is. Yeah. I can integrate that. So I'm actually good to go here with my integration by parts. So I can rewrite this bottom part. I'm going to keep this 8 all by its lonesome. And then I'm going to multiply my diagonals together. I'm going to get -1/2 t to the -2 ln of t. And then minus this negative right there turns into a plus 1/2 integral of t to -3 dt. I'm going to get 8. I'm going to shoot with that 8 in a moment here because I can already tell it's going to get nasty. I'm going to rewrite this part too. Integral, this one is going to be -1/4. I'm going to get rid of that minus sign. -1/4. Because it's going to be 2 to the negative, it's going to be t to the -2. So -1/4 because it's 1/2 times 1/2, -1/2 t to the -2 plus c, distribute that 8 all the way through, and I'm going to get -4 over t squared ln t minus 2 over t squared plus 8c, which is a new constant. Let's call it k. I'm just going to double check I did this work right from what I've done in previous years. Yeah, go me. So I'm going to take this pink. I'm going to substitute it right back in where blue was, and I can give it bounds and everything like that. So we're going to use the limit as x approaches infinity of -4 over t squared ln of t minus, yeah, 2 minuses, minus 2 over, not t, I'm at, no, I am at t's right still. I'm still in t's. 2 over t squared. Evaluate that from 1 to x. So I'm going to do the limit. So x approaches infinity. I'm going to substitute that x in now, so it's going to be -4 over x squared. I'm going to put the ln of x on top there. That might help us out recognize what the heck is going on. Over 2 over x squared minus, if I substitute in a 1, I'm going to get ln of 1, which is going to zero everything out right there. So I'm going to get 0 minus 2. Hey, we got x squared grows faster here than ln of x. Hopefully you knew that. So that's going to zero out. That's going to zero out as well because that grows faster. Is my final answer 4? It is. It's going to be 2 plus this whole entire thing becomes 2. That was a lot of work. Holy cow. Who the heck would write a question like that? Jerk. Maybe that's why you need to be watching my videos. Come on. Now on to the multiple guess section of the test. So we're going to evaluate this integral right here. These, by the way, on this version, whenever I make my tests, I usually mix and match some types of questions. But everything on here is going to be those integral types of problems which are tougher, which are offered in BC only and nothing else. So when we go ahead and evaluate this right here, I'm looking at that and I'm thinking partial fractions because it looks like the bottom there is factorable. So I can rewrite that as partial fractions. Oh my God, why did I write this question like this? Integrate from 0 to 8 of 9 over that factors. If it doesn't, I wrote a bad question. 10x and x, 1 and 1, plus plus. So now I'm going to rewrite this 9 all over 10x plus 1. X plus 1 equals a over 10x plus 1 plus b over x plus 1. So I'm just doing this so I don't need the parentheses there on the first one. I'm just doing this so I can rewrite this using partial fractions. So I can rewrite this one big fraction as two separate fractions. That's two fractions because I have two factors. So now I'm going to multiply everything here by my denominator on the left-hand side. So I'm going to get 9 equals a x plus 1 plus b 10x plus 1. Now I'm going to pick and choose values. I'm going to let x equal -1. That way I can eliminate the a term. So I'm going to get 9 equals 0a, or a times 0, I guess would be more official looking, plus -10 plus 1 is -9b. So b is equal to -1. Yeah, sure. I'm gonna look at my work over here. That's what I got. B is -1. And then I'm gonna pick out an x equals, oh God, -1/10. Ugh, it's ugly. I do that to eliminate the b term. So I'm gonna get 9 equals a times 9/10. So 9/10 a plus b times 0. So b zeroes out, it's gone. A is 10. That's what I got. So I can rewrite this now up here as 10 over 10x plus 1 minus 1 over x plus 1, which I can integrate that part much easier. So I'm going to come down and rewrite this entire thing as the integral from 0 to 8 of, oh gosh, I already forgot what it was, 10 over 10x plus 1. Be careful when you integrate that, by the way. That's a u sub. People miss that all the time. It's like, wow, what are you doing? X plus 1 dx. I'm going to do a baby u sub on that one. When I integrate over here, I'm going to get 10 times 1/10. So it just becomes ln of absolute value of 10x plus 1. Minus ln of x plus 1. Sure, yeah, sounds good to me. Again, be careful on this one. This is going to produce a 1/10, a factor of 1/10 when you u sub. I'm not showing you the u sub. I don't think, if y'all are at this point in the course, y'all should be sharp enough to realize this is a u sub with a factor of 1/10. So it's 1/10 times 10, which cancels out, gives me just a 1 in front of this ln of x. Substitute in the 8 into the 0. I'm going to get ln of 81 minus ln of 9 minus ln of 1, which is 0. Minus ln of 1, which is also 0. So I got ln of 81 minus ln of 9. Does that match up any of my answers? It does not. That doesn't mean you're wrong. Let's just rewrite this. ln's, we can combine those into one thing. If I divide, this is the same thing as ln of 81 over 9, which is ln of 9. Is that a choice? Sure is. It's what I got in years past as well. All right, there you go. That's our first multiple guess question. With this next question here, scrolling down on my key just to make sure I don't do anything stupid. We do have calculator question here. There's nothing important in the calculator here. I can just calculate. There's nothing like calculus-y in the calculator. You just need to be able to plug in values. So I think we're good to go. Let g of x be a twice differentiable function. Evaluate this integral right there, where g of 0 is 2, g of root 3 is 7, g prime of 0 is -1, and g prime of root 3 is equal to -4. I remember writing this question up, and I just could not find values that worked. So that's why I ended up using square roots. This ended up being a calculator question. So when you see this function notation, it looks kind of like a little bit like product rule, right? Like 2x times g double prime, that's a product rule. Whenever you see some type of product inside of an integral, it's not product rule, but we're going to use integration by parts to pull apart the product part of the product rule. So we're going to integration by parts. I've done this on the previous FRQ. It's right here. So kind of the same idea. I'm going to have a u value and a v value. So u, I'm going to have a v. We start with a plus, and then we go to a minus. Algebraic is going to end up being my, I don't want to take derivatives with this. I don't want to take derivatives of g prime because I don't want to get to g triple prime, g quadruple prime. I don't have those stuff, but I do have g prime. I do have a g, so I want to be integrating g double prime. So let's keep that over here. And then I'm going to get 2x over here. All right, when I do that, I'm going to derivative of 2x is 2, and then the v becomes g prime of x. All right, and actually I don't have the integral of 2 times g prime of x, so I'm actually going to do this one more time. It's a little bit of a trick if you haven't learned the trick yet. Whenever I'm in algebraic, if you can get the u's down to a 0, it makes life so much easier, because if I were to multiply these together, I can integrate 0 times g of x dx, because it's just going to be 0. So a little bit of a trick there. If you can get the bottom row to be a 0, it's great. You don't have to. You can do this problem without doing that little trick. But we're going to end up with 2x g prime of x minus 2 g of x. Evaluate that from 0 to root 3. All you do is just plug in values now, and you have a lot of this information here. So we're going to get 2 times root 3 times g prime of root 3, which we're given, minus 2 times g of root 3, again, which we're given, all that stuff right up here, minus, plug in a 0, I'll put parentheses around that, so that's all that, minus, plug in a 0, we're going to end up with 0 minus 2g of 0. So it's 0 times g prime, which is just 0. 0 minus 2g of 0. Which I have g of 0, and I have g of prime of 0, which doesn't really matter at all. So when I calculate all this, you just trust me. Use your calculator, get all this stuff in. You're going to get C as an answer for this one. All right, number 4 deals with trig sub. I'm going to tell you a little bit of a secret here to my students. I don't ever tell you this, but I'll tell you this right now. Trig sub is not on the AP exam, but I have it on my tests and my exams and everything like that because I do value trig sub a lot, because you can use trig sub to prove all of our inverse trig integrals, and plus it uses a part of u sub, so I usually don't do hard questions on my tests for trig sub. They're usually kind of sort of set up like this. It's just, hey, what's the u substitution part of it, because you still need to use u sub, so I do value that part of it. So that being said, you might want to know how to do a question like this. So when trig sub is used to evaluate this right here, which of the following integrals is obtained after the substitution? So we do have a plus here. I've taught my students if you have a squared plus, I don't even have the answer in front of me for this one. If you do have a squared plus x squared, you're going to have to use tangent as a sub here. So we're going to let x equal tangent theta. So now you're going to get dx equals secant squared theta d theta. So by doing the substitution, I'm going to replace all my x's accordingly. So this x becomes, x to the 4th becomes tangent to the 4th theta. Square root of 1 plus tangent squared theta. And then dx is going to be secant squared theta d theta. 1 plus tangent squared is going to become secant squared. So this is just square root of secant squared theta, which is just secant theta. So I can clean all of this stuff up here. This becomes tangent to the fourth theta times secant theta times secant squared theta. Hopefully you can see the answer right now. Combine my secant together, we're going to get tangent to the fourth theta times secant to the third theta d theta. I do see that answer pop up. A little bit different order, but it's going to match up right here. So that's all I'm expecting for these trig sub questions for the most part. Either you can do them because they're simple enough. This one would really be terrible to continue on. That's not a pretty integral. You have to change everything into substitution's not going to work. You have to turn everything to sines and cosines and play around with a bit. But usually if it's on my test, it's not nasty or it's like one of these problems. Last one here. Thanks for sticking around. I appreciate it. Or maybe, you know what? No. I don't appreciate it. You should appreciate it. All the knowledge I'm giving you. Why am I thanking you for watching my video? I've got nothing out of this channel. I want to be done doing this channel because I've got nothing out of it. But maybe you learned something, and that's, by gosh, that's all we want to get out of this, right? Is you learning. That's all we care about. Is you learning. So maybe you should subscribe and watch the other videos and stuff like that. If I get more subscribers, maybe I'll do more of this stuff, but if you don't subscribe, I won't do more. Determine whether the improper integral from 4 to infinity of 6 over x to the third converges or diverges. Evaluate the integral if it converges. All we're going to do here is just rewrite this as a limit statement. Let's go ahead and rewrite this as limit as, well, let's do b. I don't want to do x. Let's talk about b because it's the top bound. You don't have to use b, but I usually do. It's the top bound. From 4 to b of 6 over, actually, I'm going to rewrite this differently. 6 times x to the negative 3 dx. I feel like I keep integrating x to the negative 3 in this entire video. We did this in the free response. Yeah, so I'm going to integrate this. I'm going to get negative 1/2, which is going to give me negative 6 times negative 1/2 is negative 3. X to the negative 2. 4 to b. Yeah, sure. 3, right? Let's make it look nicer. Negative 3 over x squared from 4 to b. And we can substitute these numbers in right now. And you're going to end up with negative 3 over b squared minus negative 3. So how about that? Plus 3 over 4 squared. So this actually ends up being a 0. Zero's out. And this is going to end up equaling 3 over 16. So 0 plus 3 over 16 is going to give me this answer of A. Hey, real quick, don't cut out yet. Let's get some knowledge. You're here. Get some knowledge. I knew this converged right away. I knew it because this growth right here was pretty small in terms of it didn't grow fast enough for this to diverge. I know that because whenever I'm integrating anything over 1 over x to the p dx, if p is larger than 1, we're going to converge. All right, put that in your pocket there of knowledge. This is going to come back when we start doing series, but if p is greater than 1, we're going to converge right there. So I knew that converged, so I knew right off the bat it was indeed. Just got to go through the whole process. And that's going to wrap up our video here. Again, like and subscribe for more content. Who knows? Maybe I'll be back sooner than I anticipate.